Okay, well, this is quite humorous. I don't know why I even bothered, but there's the definitions that I should have gone over in the last video. But go ahead and write those in your words worth knowing. So today we're going to be defining periodic functions. So all this really means, this word periodic, is that the same thing repeats every so often. So it's kind of like define repeating functions. That's what it means to be periodic. So let's start with the periodic property of sine and cosine, which you can think of as the repeating property of sine and cosine. I'm going to start out with bogging your mind down with y. I'm going to let that fester a little bit overnight, but I'm also going to show you some examples to try to give you something concrete. So y. Well, let's start by drawing a circle. We're working with the unit circle here. And I figured out that the unit circle is used a lot to prove to us different things that we wouldn't have been able to otherwise prove. So let's just start with an angle T. All right, and a point P right up here. And we're going to call the coordinates, oh great, it's frozen. Great. Okay, there you go, catch up. So we're going to have an angle T, and we're going to name the point P, and the coordinates are x and y. But we just learned in the last lesson that we can also write those coordinates as cosine of t, comma, sine of t, because in the unit circle, x and cosine of t are equal, and in the unit circle, y and sine of t are equal. All right, so that's our starting point. But now I want you to think about what happens when you go one full circle around. How far did we go? How many radians was that if you make a full circle? Well, hopefully in your mind you're thinking that's 2 pi, because that's correct. One full rotation in a circle in radians is 2 pi, which means that if we thought about the angle from here, I'm maybe going to do it in red, from here all the way around, how far did we go? Well, we made one full rotation and t more. So we just went 2 pi plus t. Okay. So we ended up on the same point again. I'm pointing to it, but we ended up on the same point again. So this time let's call it Q, but it's still the same point. Okay, it's still x comma y. But to get to Q, our angle was 2 pi plus t. So whenever we refer to it, the coordinate in terms of trig functions, we're going to say that it's cosine of 2 pi plus t, comma, sine of 2 pi plus t. And the reason being, this is our angle whenever we go one full rotation plus t. So we need to change our angle a little bit. But what's interesting here is you end up at the same point. X and y are equal, or x and x are equal, y and y are equal. If these are equal here, that means these are also equal over here. That means sine of t is the same as cosine of pi over t. And it also means that sine of t is equal to sine of 2 pi plus t. Okay, have I exploded your brain yet or make you want to pull your hair out? Well, now we can write our identities. Basically what this all tells us is that if you have sine
Attention students, at this time after school, RTI is over. If you ride a bus or board out front, if you walk, you're free to go. Thank you.
you're all free to go. No, I'm just kidding. Okay, so sine of 2 pi plus t is the same as sine of t. So the ratio that you would get from your reference angle of this big angle is the same as the ratio you would get from this little angle. Same thing for cosine. Cosine of 2 pi plus t is equal to cosine of just t. Okay, let's do some examples. So, say we have cosine of 420 degrees. The way we did it in the past is we would just quickly sketch out the reference angle. Okay, so we'd do something like this. We'd go all the way around. There's 360. This is 450, so I know I'm going to be somewhere in here. And then do 420 minus 360. Okay, I know this is 60 degrees, la da 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 da. Doing all this little work. Okay, and then you'd use your little reference triangle and you'd be like, okay, square root of 3 over here, 1 here, 2 here. All right. This can help you to not have to do all that sketching. Okay, cosine of 420, you can find that by using this identity. Here's how we use it. We change cosine of 420 into cosine of 360 plus whatever. 420 equals 360 plus what? Well, just do a little mental calculation and you'll figure out that's 60 degrees. So our identity says that cosine of 360, that's what 2 pi is, cosine of 360 plus an angle is the same as just cosine of the little angle. So we can say, oh, this equals cosine of 60. And now, if you know cosine of 60, you just write it down. It's 1/2. And you're done. So this is how you use the identity. You break the big angle into a full rotation and the little angle. And then you can just basically forget about the full rotation because it doesn't change our answer. And we just find cosine of the little angle that's left over.